Hi everyone, thanks for joining us again for our talk after lunch. This talk is called SBOMs Are Coming, How Will Python Help by Anthony Harrison. Anthony is an experienced solutions architect and cyber consultant from the UK. They're an active developer of open source tools in Python, and in his spare time, he teaches Python to students, youths at Manchester Coder Dojo, as well as running both Road and Trial. I would also like to add, since this is a pre-recording, the audio may be a little bit muffled for in person, so recommend if you have difficulty hearing the audio, you can also read or watch captions in the Fletcher Theater outside to your right. And also, we are streaming the talk on YouTube, so if you want to watch YouTube on your phone or laptop, put on silent to read the captions. And yeah, let's begin.
Good afternoon. My name is Anthony Harrison. It is my pleasure to give this presentation on software bill of materials and how Python can contribute to this increasingly important topic. Our agenda this afternoon will provide a brief introduction to software bill of materials before describing a number of Python tools which will assist you in using SBOMs, typically as part of a DevOps or DevSecOps pipeline. I will then conclude with a brief summary and a list of resources. But before we start, let me introduce myself. I'm Anthony Harrison and I'm based in Manchester in the UK. I'm currently an independent consultant, having spent many years delivering mission-critical solutions across a number of sectors. I'm a great advocate of open source and I've been a Python developer for the past 10 years. My introduction to Python being through the Raspberry Pi. I support a number of educational outreach programs, introducing the wonderful opportunities that technology can bring, including Coder Dojo, where I teach Python to students, and the Google Summer of Code, where I act as a mentor. In my spare time, I'm an active runner, taking part in both road and trail events throughout the year. So let's get started with 3 questions, which hopefully at the end of this presentation, you'll have given you some answers. Firstly, why do I need an SBOM? And secondly, having understood why we need one, how do I go about creating one? And finally, what can I do with one? But I want to take the first question and add, why do we need it now? It's quite simple. Everyone is or should be worried about cybersecurity in their organisations. In particular, how secure is their software that they are developing or using, and how resilient is it to vulnerabilities? But I think this is hiding a major concern, an even bigger one, as we increasingly rely on third-party frameworks, applications and libraries to develop our solutions. Whilst these offer huge benefits in allowing us to create our solutions quickly, we no longer fully understand how our solution works. It's very much like an iceberg. We can only see the surface and we can't see what is lurking underneath. What might be lurking? So if we look at a typical Python application, we can see visually that our application, shown at the top in red, uses a number of modules which we would typically specify in a requirements file, shown in blue. But these modules require additional modules, shown in green, in order to function. These are hidden from our application. And although we install our application, these dependent modules are automatically installed onto our system. How well do we understand these dependencies? And do we understand what they are doing? And do they increase the risk to our application and our organisation? We need to increase our understanding of how our software is constructed, and we need to increase the visibility of our dependent components. This is where SBOMs come in. So hopefully I've set the scene of why SBOMs are required. Let's simply define what an SBOM is. An SBOM is simply a set of metadata which defines the set of components which a software application is composed of. It should be automatically generated. An SBOM is often compared with a set of ingredients in a product. It doesn't say how the components are integrated together, just that they are required. A recipe tells you how to use the ingredients. Your design tells you how to use your software components. Normally there are many SBOMs. Typically there is one SBOM per application. An SBOM should be used by a variety of users across an organisation, as well as provided to users of the software. The information contained within SBOM should assist any organisation to manage the risk exposure in using software components, whether upstream or downstream of the supply chain. Whilst the SBOM concept is more than a decade old, various initiatives primarily related to improving software security and resilience over the past 2 years have significantly raised the profile of SBOMs and awareness across industry and governments across the world. A major catalyst was the US President's exec order in May 2021 on improving the nation's cybersecurity. SBOMs were identified as a key enabler of providing greater transparency in the way software is constructed. Then at the end of 2021, the Log4j vulnerability was discovered. As with any major vulnerability, organisations were busy working out whether they were impacted and using the affected module. If organisations had had an SBOM, it would have been very easy to determine. However, the subsequent analysis also identified how many applications were unaware that they were using Log4j implicitly, although the applications weren't explicitly using the component. Last year, Linux Foundation produced a research report on the readiness of organisations to use SBOMs. It further identified the growing importance of SBOMs being a key component in managing the software supply chain. And then following the report, OpenSSF launched the SBOM Everywhere initiative with a remit to increase awareness and education about SBOMs, as well as providing greater tooling. Over in Europe, the EU and the UK have both got launched initiatives to improve software security and resilience, of which SBOMs form a key component. So there's a lot happening. There are 2 primary standards for SBOMs. SPDX has been around for more than a decade and is an ISO standard and supports SBOMs in a number of formats. Cyclone DX is a simpler format and is a community standard originating out of OWASP, and it supports SBOMs in JSON and XML format. Although there are 2 formats, there is good interoperability between the 2, so that SBOMs in one standard can be transformed into another. Regardless of the format, an SBOM consists primarily of 3 sections. SBOM metadata identifies the author of the SBOM, the tool used to create it, and when the SBOM was produced. The main section of the SBOM details the software components which are used by the application. A component could be as simply as a source file, or it could be a library or compiled module. And finally, there is the detail of the relationships between the components, e.g. component A depends on component B, and we see this in Python when the Python module imports a non-standard library module. An SBOM is a snapshot of time. Over time, the content of SBOM will change as further information becomes available. The metadata associated with a component is the critical part of an SBOM. There is a recommended minimum set of attributes which should be provided for each component as shown on this slide. As we'll see later, there are a number of challenges in meeting these requirements. An SBOM is a living artifact which is continually changing throughout the life cycle. An SBOM can be used for numerous activities, e.g. assessment of third-party components, through to checking that a software build consists of the correct packages. As I said earlier, SBOMs form a key part in supporting risk management, so SBOMs can help confirm that the only approved licenses are used to identify any vulnerabilities in the components and to help detect out-of-date or obsolete components. An SBOM should be of interest to everyone. Developers and operations should be using SBOMs to help monitor the components being used and identify any vulnerabilities. Security and compliance teams should be using SBOMs to manage the risks that may arise from the use of such components. SBOMs should be being produced by all parts of the supply chain, from developers to integrators, and if you produce an SBOM, you should really be using the SBOM as well as part of your development lifecycle. SBOM used by an end user will be dependent on its circumstances and its relationship with its solution provider, but it should be providing transparency to ensure effective risk management can be performed at an enterprise level. So now we have set the scene for SBOMs. Let's get moving to look at a number of tools and see how they can be used across the development lifecycle. Whilst there's a growing number of tools starting to appear, all of these tools in the following section have been written in Python and should operate both on Linux and Windows environments. All tools will work with both SPDX and CycloneDX formats and are available to download from PyPy. The first set I'm considering are related to the creation of an SBOM at different stages of the life cycle: the development, the build, and the integration phase. So the first tool, SBOM for files, is typically used during the development phase. It can extract license and copyright information from the tool where possible. This might be useful to verify that all the source files have correct licenses and copyright information. Checksums can also be generated, which then allows integrity checks to be performed later in the subsequent build process. SBOM for Python creates an SBOM for an installed Python module, typically during the build phase. The major goal of this tool is to extract all of the dependencies, not just the direct dependencies, for a module. We saw this visually earlier. However, this is where the Python community really needs to help. The information used in generating this SBOM uses the metadata associated with the module. If the metadata is incomplete or incorrect, information will be missing from the SBOM. And finally, Distro to SBOM is used typically aimed at the integration project to capture all of the components within a solution. The tool can create an SBOM for an installed module. Currently, Debian and RPM-based systems are supported, and identifies all of the dependent packages in a similar way to the previous tool. However, for my use, it is very clear that the level of information readily available isn't currently consistent between distributions. The tool can also be used to produce an SBOM for the complete distribution, which may identify all of the components in the distribution. We can see this use later. However, there are a number of challenges. It is very clear that SBOMs are heavily dependent on component metadata. One of the observations I've noticed is inconsistency in the specification of licenses. As you can see on this slide, there are multiple ways of specifying the Apache 2 license. only one of which is correct, the last one. The SPDX organisation have for a number of years published a list of license identifiers to try and gain consistency across industry. It's clear that this still isn't happening. So whenever we are looking at a license for the Python module, or any module, try and make sure it is using a valid SPDX license identifier. This will increase the quality of the license data captured within an SBOM. Another issue is consistency in the naming of components. This is a major issue, particularly when using an SBOM to check for component vulnerabilities, using data from one of the vulnerability databases. CPA data is often inconsistent. Perl data may provide additional context, e.g. it might show that it's a Python module, but this isn't widely used at the moment. You may have noticed in the previous SBOM for Python tool, it tries to generate CPE and Perl references, but this is generated from the metadata. So if the metadata is wrong, so will the generated values. And finally, understanding the supply of a component. This is also related to the previous comment, but basically the supply will change as components get subsumed into a distribution or solution. But one of the biggest observations I've seen is that one SBOM is not enough. You should be using them on a regular basis. And one of the open source projects that I'm involved in produces SBOMs every week, and it is fascinating to see how much changes on a weekly basis. If you deliver a Python module which can operate on a range of platforms and versions of Python, you should be generating an SBOM for each Python version. And if you have a platform-specific dependencies for each platform as well. There currently isn't a standard way of specifying the version of Python within an SBOM, although CycloneDX does offer some properties which could be used. So now we can create an SBOM through the various stages of the lifecycle. How can we start to use them? So the next set of tools is related to the management of SBOMs. Remember that I said earlier that SBOMs were increasingly being used to support a cybersecurity strategy. There are clearly a number of use cases which support this, but there are other cases identified here, e.g. change management. A key one to me is determining the vulnerability status of a component, but we'll discuss this more later in a later slide. The SBOM Manager helps manage the collection of SBOMs. The tool provides a repository of components which have been included as part of a release or a build. As we said earlier, multiple SBOMs are likely in a solution. It provides tools to answer some common questions and is intended to enable regular records of SBOMs to be maintained. It can be used to support audit needs in determining if a particular component or version has been used. Typical use case may be to have copies of all your distributions under support so you can readily see which customers may be affected by a particular vulnerability within a component. An SBOM generated by Distro to Sbomb would be ideal for this. A byproduct of this might enable you to consolidate your software components because it might enable you to identify if multiple versions of a component are being used. We can also see here the happy day scenario for Log4j. If we are creating SBOMs continuously through our developments, it is essential to keep track of changes and monitor them. This tool makes this simple as it's possible to see if a component version changes between two SBOMs. And this will identify if a new component has been added, or a component disappears, or even license changed. This tool actually compares two SBOMs in different formats if required. And finally, how good is the SBOM? As we've seen, an SBOM is heavily dependent on externally sourced metadata, and this tool reports on a number of key attributes of components within an SBOM. It identifies missing licenses which aren't valid SPDX licenses, and for Python modules, if the licensed version is being used or not. It can also check if the minimum content for a component as specified by the NTIA has been achieved. This tool also provides an allow or deny list, which could be used, for example, to limit the licenses which can be used within an SBOM, e.g. report if a GPL component is being used. We can see an example of this on this slide. And finally, how can SBOMs be used to help govern a project or organisation? The first one is to use SBOMs as part of vulnerability management process, which is obviously a major use case for all SBOMs. But I won't say too much about this now because there's a talk tomorrow at 2 p.m. where my friend Terry Oda is presenting further details about this tool. A second activity is to look at the license use for components throughout the hierarchy of dependencies. This tool takes an SBOM and generates a visual representation of the dependencies with the licenses shown for each component. Whilst it isn't possible to automatically identify if all the licenses are compatible, this should be a useful way of identifying if there are any license concerns, particularly for the transitive dependencies. And finally, not all users of SBOMs are going to be fluent at reading JSON formatted documents. So this tool takes an SBOM and produces a human readable representation of an SBOM, probably very useful for the security and compliance teams. So hopefully you now have a better understanding of SBOMs and can start going in the right direction. There are still a number of challenges, but I think as a community, these will be overcome as SBOMs become more widely adopted. I think I've shown how SBOMs should be now an integral part of your development lifecycle and identified a number of Python tools which might be useful to add to your toolset. I would strongly encourage you to start to generate an SBOM every time you install a new Python module and then regularly scan this for vulnerabilities. I think you may be amazed at what you discover. Whilst SBOMs provide enhanced dependency management capabilities, they will also offer far more information about the supply chain and help you to make effective risk-based decisions. But for SBOMs to deliver the benefits that governments and organisations are looking for, we need to ensure that the data that is included within SBOM is correct. And as a Python community, we have a key role to play in ensuring that the quality of the data in our modules is as accurate and as complete as possible. So let's get starting at making small improvements to our modules. So hopefully now you can answer these questions, and you can probably come up with many more. Finally, here are some links to a few SBOM related resources which have been referenced throughout this talk. All of the applications referenced are available on PyPy. The latest versions of the tools are available on GitHub. There's also a link at the bottom there to an article which I wrote last year on using SBOMs to support risk management, which may be of interest. So thank you for your attention. I look forward to any questions or feedback. Goodbye.